Hello, my dear boys. I think all of you are well. In this chapter, the name of our chapter is current electricity. In this chapter, we had learned about the flow of current, the resistance, the loss of resistance, equivalent resistance, combination of resistance, the cost, how to calculate the cost of energy, and more how to calculate the more cost of energy and power. Let's Today we will solve another mathematical problem. We will solve another mathematical problem combining all of these topics. Okay, this is a very interesting math. Please continue with me. The math is the problem. Mathematical problem is circuit. This is the given stem. This circuit is our given stem. Here we can see that this resistance is 2 ohm. This resistance is 4 ohm. This resistance is 6 ohm. This resistance is 3 ohm, and this resistance is 2 ohm, and the given EMF or electromotive force is 12 volt. Okay, then our mathematics number of math C is calculate the equivalent resistance of the given circuit. I'm repeating. The question number C is calculate the equivalent resistance of the given circuit. Okay. Then I give you the question number D. Question number D is what what amount what amount of money is to pay a electric bill for bill for 1 month 1 month 1 month if the given circuit run for 6 hours per day. Here I'm repeating this mathematical problem. What amount of money is to pay a electric bill for 1 month if the given circuit run for 6 hours per day, and also given that price price per unit is taka 5, and 1 month is 30 days. Is equal to 30 days. Okay, the price per unit is taka 5, and 1 month is 30 days. Okay. Okay. Then we are going to solve this mathematical problem. First we solve the question number C. Okay, solution. again I'm repeating, in our question number C, we need to calculate the equivalent resistance of the given circuit. For calculating the equivalent resistance of the given circuit, first of all we need to name all of these resistance. We can give the symbol or name randomly. We can write this resistance as R1, this resistance for R2, this resistance for R3, this resistance for R4, and this resistance for R5. Okay. Okay. Then we can see that the resistance R4 and R5 is in series circuit. Why? Because this in this point the currents are dividing into two parts. Okay, no, fine, no problem. But this part is flowing with these two resistances. The same part of this current is flowing with 3 ohm resistance and 2 ohm resistance. So we know that if the current are if the current is same for every resistances, then we say that these two resistance are in a series connection. Okay. Then we can write R4 and R5 is in series. So we can write R is 1 equal to R4 plus R5. So we get 3 plus 2 or 5 ohm. Okay, this is our first equivalent part. Okay, then we can this is not mandatory, I am showing you for your understanding. With these two resistance we get one equivalent resistance, and that is RS1. Then we can write this resistance as RS1 for 5 ohm. Okay, then we see that in this part the current is divided into two parts. So we know that if the current is divided into two parts, then the resistances are in parallel connection. So we need to calculate the equivalent resistance for these two resistance by using the laws of parallel connection, parallel equivalent resistance. So we can write R3 and RS1 are in series. So we can write 1 by Rp equal to 1 by R3 plus 1 by RS1. So we can write 1 by 6 plus 1 by 5, 1 by Rp. So we can write 1 by Rp equal to 30 by 11 by 30. So we can write Rp as 30 by 11. Or we can write it as 2.72 ohm. Okay. Okay. Then we can moderate this figure by that. with these two resistance we get another equivalent resistance, and that is Rp. So we can write this as Rp equal to 2.72 ohm. Here we see that the three resistances are in series because the same current flows with these three resistances. So we can calculate the final equivalent resistance by using series combination, by law of series combination. So final, here we can write R1, R2 and Rp are in series. So the final equivalent resistance is R1 plus R2 plus Rp. Here we can write 2 plus 4 plus 2.72. Then our final equivalent resistance is 8.72 ohm. Okay, this is our answer for question number C. So we can write the the equivalent resistance for this circuit is 8.72 ohm. Okay. Then we will calculate the cost for this circuit. Okay. I'm removing these resistances and this circuit. We don't need to the circuit for calculating the question number D. So first of all we can write the energy consumed by the given circuit is W equal to PT, or we can write, we know that P equal to I square, so we can write I square R into T. Here our given equivalent resistance for this circuit, we can write the equivalent resistance into T. Our equivalent resistance is 8.72 ohm, and our given current, we need to calculate the current. We can the flow of current is I equal to E divided by R equivalent. So we can write 12 by 8.72 as 1.37 ampere. Okay. Then we get I and R. Then we need to calculate the time. The time is total time for 1 month. Total time for 1 month, and for every day we use this circuit for 6 hours, and for 30 days the time will be T equal to 6 into 30. So our total time is 180 hours. Okay, so we get all of our required terms. So we can write 1.37 square into 8.72 into our total time is 180 hour. We can see that our this energy, the unit of this energy in this position, the unit of our energy is watt hours, but we need to convert it by kilowatt hour uh, for uh, for calculating cost of energy. So we need to divide it. We need to divide it by 1000. Okay, then we get then we get W equal to, by calculating we get 2.97 kilowatt hours. Okay, okay, then this is our total work consumed by this circuit. Now we will calculate the bill for this month. Therefore, bill in that month is equal to 2.97 multiplied by the cost per unit current, and the cost per unit current is 5 taka. So we can write taka 14.86. Okay, so we can write the bill. Therefore, the bill for the bill in that month is taka 14.86. Okay, for this circuit, our given bill is 14.86. So this is the method for calculating this type of circuit or this type of mathematics. So you need to practice at home for calculating this type of math. So we will discuss more circuits with our next classes. Until then, thanks all of you.